Thursday, we learned 4 ways to show that something was unique. Please take the time to write these down again. S, 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 which stood for side, side, side. Please write them down. Please write them down. Please write them down. What this tells you, if they give you 3 sides measurements of a triangle, then it's going to be unique. If we were all given the same measurements, 3 inches, 4 inches, 5 inches, and we all drew the same triangle, they would in fact all come out the same way, no matter what you do. You were given this, SAS, which stood for side, angle, side. And what's important to understand is that that angle had to be caught between the 2 sides. And what it would look like is it would look like this in a triangle, where you can see that this angle is caught between the 2 sides that are there. You were given this, angle, side, angle. And again, it's important to notice that the side then is caught between the 2 angles. And again, if I were given a triangle, it would look like this, where I'd been given an angle, I'd been given another angle, but I was given the side that was caught in between then these 2 angles. If I took these 2 angles and pushed them together, this side would be caught in between them. And the other rule that you were given was this one, HL, which stood for hypotenuse, leg. And remember that this only exists if you have a right triangle and it would look like this. The hypotenuse would be the side that was across from the right angle. This is the hypotenuse. And either one of the other 2 sides then would be a leg. These are the only 4 methods that will force a triangle to be unique or congruent, where there is only one triangle that can be drawn. If we've been given the same information and we draw it out the way we're supposed to draw it out, if we cut them out of the sheet of paper and stack them in a stack, all of the triangles would be, in fact, exactly the same. They'd be congruent. If it doesn't fit one of these categories, then there's one of 2 choices. There's either going to be no triangle or there's going to be many. The only way that no triangle exists is if it doesn't fit the other rule that we learned that went with side, side, side. I'll give everybody a chance to copy what's up there. I see a couple people still copy. Okay. Listen, we learned one other rule that said this. The sum of 2 sides must be greater than the 3rd side. In other words, if you're given a triangle and you're given the sides, A, B, and C. If you take the two smallest sides, and for this one we're just going to say it's A and B, then it has to be greater than the third side, which would be the largest side. So whatever A plus B is, it has to be greater than C. If it doesn't meet this condition, no triangle exists. If I gave you the sides 5, 5, and 10, is 5 plus 5 greater than 10? No, it will not make a triangle. In fact, it'd fold down and make a straight line. If I gave you the sides 3, 5, and 10, could I make a triangle out of that? No, 3 plus 5 is not bigger than 10. What about 5, 7, and 10? Yes. And in fact, it would be unique because they've given us 3 side measurements. Side, side, side. So, there are 3 possibilities today that you're going to deal with. It'll either make a triangle that is unique, it'll make many triangles, or it'll make no triangle. In order to be unique, it has to fit one of these 4 categories. In order to be no triangle, it can't meet this. If it meets this, and it meets one of the other 4, it's unique. If it meets this, and it doesn't meet one of the other 4, then there's many. It's that simple. So, we're just going to look at a couple quick examples. You do not need to write the examples down. Chances are you already have some of them written, because I put some of them up on the board on Thursday. But the rules you're going to want to go back and reference again today. Okay, that's why I had you write them again, is you might not have them written, or you might not have them with you. You might not have been able to find them. And the more times you write down a rule, the more likely you are to memorize or remember that rule. Those 4 rules are key to everything you're going to do today. Okay? So, if they give me, if they give me this, and they ask me to tell whether this figure creates conditions that would form unique, more than one, or no triangle. That's what they're asking. So it's one of 3 choices. It's either going to create a unique triangle, it's going to create a lot of triangles, or it's going to create no triangle. If I look, here they gave me a side, they gave me a side measurement, and they gave me a side measurement. This looks like one of my rules, doesn't it? Side, side, side. Correct? Yep. If it's the side one that they're giving you, you have to check to see if it makes a triangle at all. You take the 2 smallest sides. 3 plus 6. Is 3 plus 6 greater than 10? No. No triangle is formed. Although it looked like it might be unique, because it didn't meet this other condition, you can't make a triangle given those measurements. Everybody understand that one? Be careful when you're looking at a problem like this. Take the time to label the information that they've given you. What is this that they've given me? Is it an angle or a side? It's an angle. Label it. This is a, and this is an angle. please notice that if I pushed my two angles together, the sides caught in between them. It says angle, side, angle. Is that one of my four?
Yes.
So this one would be unique. But he's still with me. Understand what they're asking.
Wait, so we take two smaller ones and add them.
Thank you. Okay. In this particular problem, it has nothing to do with having to take the two smaller ones, because this is dealing with angles and sides. The only time you're going to take the two smaller ones and see if it's larger than the largest is if it's all dealing with what? Sides. That makes sense? This, they gave me angle, a side, and an angle. What they're saying is if I drew a 60-degree angle, I connected a 4-centimeter segment, and we drew another 60-degree angle, that no matter how we tried to draw it, when we connected these up here, everybody's drawing would, in fact, be exactly the same. That's what it says. Okay? On this one, what did they give me? They gave me an angle here. They gave me a side. They actually gave me what? What does that say? No, what does this say? How big is this? Which means it's 90 degrees. It's an angle. Is this unique? Yes. Because they've given me an angle, a side, and an angle again. Everybody still with me? We understand what it is. What if they gave me this?
It would be side, angle.
Okay, this is a what? That's a side. This is a what? And this is a what? Side. It doesn't have a degree, and if it's an angle, it will be marked on the inside. Okay? Now, with that being said, if it is side, 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 I've got to make sure that the two smallest sides added together, 3 plus 22, is that greater than 24? So this would be unique. Okay? But you still understand? What if I told you that this was 40 degrees, this was 10 centimeters, and this was 20 centimeters? This would be angle, side, side. Okay, now wait a minute. I see some people have read it, and here's what's important to recognize. It's easy to tell this isn't going to work. There are no donkeys, there's no butts in geometry. Look at it. Look at it. There are no donkeys or no butts in geometry. Oh!
I know.
We're not going to say it. What's another name for a donkey?
A jackass. Yes.
Okay. Look at what's up there. This says angle, side, side.
Why are you putting that up there?
Listen.
Oh my God.
Listen. Is this one of the four?
No.
Okay. So if it's not one of the four, then there's either none or there's many. Did they give me 3 side measurements?
No.
They only gave me what? 2. Can I figure out anything? If it's not that way, this one has many. In fact, if we were given a 40-degree angle, a 10 centimeter side, and a 20 centimeter side, in fact, when we tried to draw them, there's a very good chance that we would have two very different triangles, possibly more, but at least two different triangles, which means that they're not unique. Does everybody see that? So, one of four rules has to be true. Side, 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 angle, or hypotenuse leg. If it's side, 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 you have to check to see if the triangle actually exists or not. And you do that by adding two sides together and seeing if it's greater than the third side. If it's not one of the four rules and the triangle exists, then the answer is going to be many. And that is all we're doing today. All we're identifying is there one, is there none, or are there many? Okay?